So when we are done with today's lesson, you should be able to describe linear programming, and then you should be able to describe the types of line that we deal with when we are looking at linear programming. And you should be able to describe the nature of lines, and then you should be able to present the inequalities on a graph. So what then is linear programming? So linear programming is actually the study of inequalities. And then the question may be, what are inequalities? So inequalities are simply mathematical statements that involve inequality symbols. So the inequality symbols that we look at include less than, greater than, less than or equal to, or greater than or equal to. So those are the inequality symbols that we look at. Don't you worry about the notes. I will actually send you the slides. For now, focus on understanding the concepts. Then, let's look at the types of lines. So we have what we call vertical lines. Now, these vertical lines, you can see the yellow ones are the vertical lines that we are talking about. Then we have the X or Y plane. We have the Y axis. We also have the X axis, which is a horizontal line. So now what it is when you draw a line, which is a vertical line, as this one here, and it cuts the X axis at a point where it's equal to -3, then we're going to say this one here, this line, is denoted by the equation X is equal to -3. Are you able to see that?
Yes.
Then we can also talk about this other one, which is a vertical line cutting the x-axis at a point where x is equal to +2. So because it's cutting the x-axis at 2, then we'll say x is equal to 2, hence we have the first equation. How about the third one? How is it going to be drawn? I actually forgot to draw this line, but we can do it right now. So now, where are we going to draw it? So since it's representing the x-axis, it's going to cut the x-axis at a point where it's equal to 0. So the point at which x is equal to 0 is this one here. So the line will actually be in line with the y-axis. See that? Oh my.
X equals to 0.
Yes, at this point. Though the line aren't all that bold. How about this one? Line isn't all that bold. Okay, let me make it bold. So you can clearly see it now.
Yes.
Yeah, so we've talked about the vertical lines. The vertical lines denote the x-axis, because when you draw a vertical line to cut the x-axis. So now if we were to say we have this other equation, which is x is equal to 3. How am I going to draw that line? Where is it going to pass?
It will be where there's 3 there.
Now the +3, because the negative the negative
Best point.
integers, yep, and the positive integers, so it will pass here.
Yes.
So we are done with vertical lines. We move on to horizontal lines. So we are looking at types of line. We move on to vertical lines. Or horizontal lines, rather. So horizontal lines, on the contrary, they cut the y-axis. So say any line drawn horizontally represents the y-axis. So if let's say we have this one as an example here, say y is equal to 1, then that line will actually be drawn horizontally and it's going to cut the y-axis at a point where it is equal to 1. And this is the one that we have here.
Okay.
Then y is equal to 0. The line will actually cut the y-axis at a point where it's equal to 0, and it will be this line here in the middle. How about this other one? Y is equal to negative 2. So it will be drawn, yes, through negative 2 here. So we're done with types of line. Let's move on to the nature of lines. So now when you're looking at linear programming, a line may either be bold or it may be dotted. A line may be bold or it may be dotted. So now, what determines the nature of the line is actually the inequality symbol that is within the inequality. Okay, so I think we've skipped something here. There are some lines that are okay, fine, that's awesome. We can move forward, we'll come back to this.
Okay.
Yeah. Because we had actually started looking at the nature of lines, so I left out the other type, so we'll get back to them. So if we have dotted lines, then you need to know you're dealing with the less than or greater than inequality symbols. Hence we have these which are vertical, yet they are dotted. And these are actually lines which are given by the inequalities. Let me give you an example of this. If let's say x is equal to 3, so such a line will actually pass through the point where x is equal to 3, right? Yes. And then if we bring in an inequality symbol, we're going to have something like this. It will either be x is less than 3 or x is greater than what? 3. Those two symbols. We won't bring in these because these lines which are dotted denote these inequality symbols which I have actually written at the bottom here. Less than or greater than. And what they insinuate is that 3 is not part and parcel of the solution set. So we'll get to look at this. Let me show you something here. We may be talking of something from the abstract point of view. But we'll talk about this in the next subtopic. If this is -1, and then this is -2, we have a 1 there, and we have a 2 there. And then we say we have this inequality, that is x is less than 1. We can actually formulate an equation here. I will say x is equal to 1 so that we know where the line will pass. So the line will actually cut the x-axis where it is equal to 1. But again, we need to bear in mind that the inequality symbol that we have will determine the nature of the line. Is it going to be bold, continuous as those denoting the x and y axis? The thing is, since we are dealing with this inequality symbol, we are going to draw a dotted line. So now, if we now say, can you shade the unwanted region? Because at senior secondary level, we only shade the unwanted regions. So where is the solution set? We have this side and that side. So the inequality will only be true, or it will hold true, if we actually pick on the side which is holding the solution set. Where are the numbers which are less than +1? All the numbers are this side, right?
Yes.
So we're considering the x-axis. Here we have a +1, then we have +2. All the numbers on the right side of 1 are greater than 1. Now the side where the numbers are less than 1 is the left side. We have a 0, -1, -2, -3. All those are less than 1. So this is the wanted region, and it's also called the physical region, but that's not the one that we're going to shade. You're going to shade the unwanted region, this one here, which hasn't got the solution set. I've gotten into the next topic, the next subtopic, where we look at presenting these lines on the X or Y plane, for drawing graphs of inequalities. All right.
Okay.
Yeah. So we've talked about the inequality symbols less than and greater than. And then these slanted lines are actually given by the equation of a straight line, which is equal to y is equal to mx plus c. So this m is the gradient of the line, x is the x-intercept, y is the y-intercept. So the y-intercept is the point at which a line touches the y-axis. Then this y is actually the coordinate of the y-axis. We soldier on. Let's move on. Linear program. Okay. What of these lines which are bold?
Yes, these are different from those.
Come again? Okay.
Saying these are different from those were dotted.
Yes, so now when you see bold lines, then you need to know you're dealing with the inequality symbols equal to, as I say, less than or equal to, or greater than or equal to. So if in an inequality you have those inequality symbols, then you need to know you're going to have bold lines.
Okay.
So be it vertical, so in a case like this one, we may have x is less than or equal to 2. If we were to draw this, we would have something like this. That is 1, 2. So if we draw a line, it will actually pass here and it will be bold. So which side has the solution side? Where the numbers are less than or equal to 2 is this side, but we're going to shade the unwanted region.
Okay.
Yes. For this, you may have forgotten how to go about this.
So it's a must, you have to shade the unwanted region.
Yes. At grade 9 level, they shade the wanted region, but at your level, you have to shade the unwanted region. So these are the basics of linear programming. You need to grasp them. We won't throw them away at this level. You will continue applying them through the entire topic. We'll move on.
Yes.
Oh, what? I wonder why I keep on clicking on that. Okay, so they're saying the unwanted region is the region that does not satisfy the inequality, and the region that remains unshaded, which is the wanted region, is called the feasible region. I think I explained about this.
Yes.
We soldier on. Okay, so now here we're going to talk about presenting inequalities on the graph by shading the unwanted region. So how do you do that? That's the question we're going to answer here. So let's start with the first one. I've actually been demonstrating how to do that, but for the sake of consolidation, or consolidating on what we have done so far, you can still do this because this is specifically on doing what I've been doing. So how do you present these inequalities on the X or Y plane? So we draw the X or Y plane. And then you say here we have a 1 and there we have a 2. And this side we also have a 1 and then we have a 2. But as long as there is X this side, we know we are dealing with a vertical line, or we'll be dealing with vertical lines. X, 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 X. All vertical lines actually denote x-axis.
Okay.
We may extend this. We saw that we have -1 here. We have -2 there. Then we have -3. Then we have a 3 there. We have a 4 there. Then we have a 5 there. So we start with the first one. So this first one is saying x is greater than or equal to 2. So we go to a part where x is equal to +2. We check. So this one is the inequality symbol greater than or equal to. So the nature of the line will be bold. Very important. Bold. So now the solution set is this side, right? That's where the numbers which are greater than or equal to 2 are based, at this side. So we are shading the unwanted region, the part where the solution set isn't. So we are done. We move on to this one, though it won't fit here. -3, -4, we'll take it anyway. This is -4. Then -5 is here. So this one is x is less than -5. Is it going to be a bold line or a dotted line?
That one will be a dotted line.
Dotted line, very good. So we draw that one. Unfortunately, so we have a line like that. So we can as well indicate to say this line represents the inequality. We are showing that this one, x is greater than or equal to 2. We move on to the third one. X is greater than 0. At which point is this line going to cut the x-axis?
At 0 itself.
At 0. Up. Okay. So we draw a line here.
Yes.
Now, where is that? Now, you've seen that I've made a mistake here. I haven't noticed so. I've made a mistake because I drew a bold line instead of drawing a dotted line.
Yes, supposed to be a dotted line. It's yes.
It's greater than, so we can indicate x is greater than 0. Then we move on to the last one, that is x is less than 5.
Less than.
But there's one thing I haven't done here. Which side am I going to shade here? When x is greater than 0.
When x is greater than 0.
Yes.
The left side.
The left side, very good. So we go on to this one. X is less than 5. Which side are we going to shade?
The left again. The right.
The right side, very good.
Side.
We are done. We can move on to B now. Let me hear about everything I've drawn so far. We move on to B. This time around, we're dealing with the y-axis. So they're saying y. So you simply check the variable this side. Do you have my negative shadow? Okay. You only have 1.
Two. -1 and 2.
Okay, 3. Do you have a 4 and a 4?
We have -5.
That's negative 5.
-1, -2, and -5. -4 we don't have.
You are looking at the first one.
Oh, on the first one.
You're looking at the first one. So we have moved on to B.
Okay.
So we have 1 here. What do I have? We have a 1, we have a 2, we have a 3, and a 4 there. Then we have -1 and -2 here. So with that in place, we'll now check out the inequalities that we have. So we have y, which is less than 4. So the line will be drawn. So now check what will be the nature of the line.
We are dealing with B, eh?
Yes. So it will be dotted, right?
Yes.
Dotted. Then we move on to number 2 of B.
We are not shading on this one.
Oh, we have to shade. Which part to be shaded?
Go. Go and eat it. Go and eat. Go. Go. Oh, sorry for that.
Let's go.
The left side.
Okay, so now this time around, we are dealing with the numbers that are on the y-axis.
Yeah, at the
So-
left side.
So yeah,
Punch it.
yeah, Panishi.
One second.
So what it is, they're saying y is less than 4. So all the numbers that are less than 4 at the bottom, right? 3 to 1, 0, -1, -2. So we have to shade the unwanted region, which is the top part.
Upper part.
Yes.
Okay.
We move on to the second part. Are you able to see everything that is on the screen?
Yes, I'm able to see.
Okay, so that one is y is greater than or equal to -2, right? So the line will pass, the line will cut the y-axis at a point where it is equal to -2. But this time around, we're going to have a bold line because of the inequality symbol here, greater than or equal to.
Greater than or equal to, yes.
Yes. So now all the numbers which are greater than or equal to -2 are here on top. That's -1, 0, 2, 3, 4. All these are greater than -2. So it's this side where there is a feasible region, but we are shading the bottom part.
Okay.
Yes. We move on to the third one. I can't see that one. There's something that has popped up on the screen, so it has actually covered the screen.
Okay.
So you can shout it out for me.
Which one?
The third one.
The third one.
We've only done 2. We are remaining with a third. That's y is less than what? Y is less than or equal to?
X.
X. No, not the third, not C.
Oh, the one that, okay.
Be the third one.
The third one.
Yes.
X is equal to, X is greater than 0.
X is, oh my.
You mean which one? You see there's
Okay.
A, B, and C. Now there's the...
Okay, I want you to read it correctly. What is it saying? Y is what?
X.
Yep.
Oh, that one.
Yeah.
-2. -2. And then Y is equal to greater than.
So E 8 of job iri not to push. Sorry, I didn't space them up pretty well. Those laws in a so to share ni yapa.
Okay, Y is greater than 0.
Okay, I want you to read that inequality symbol correctly. That's less than or equal to. Y is less than or equal to 0. So you need to know what each and every inequality symbol denotes. So we will come here. So okay, this line will pass. Where is it going to pass?
It will pass at 0.
Yes. Yeah. That's where it's going to pass. Now we need to determine which side has to be shaded. Less than or equal to 0 kikwatas.
What does it?
But we are shading the unwanted region, so we are going to shade the top part.
Okay.
Yes. These are pretty simple. Okay, so now we do the third, which is C. Let's do C. So now with C, these are slanted lines. So first and foremost, we have to draw the X or Y plane. Then we have the other one here. So from here, we need to check it. For these, we have to come up with, we can't just draw them right away like this. We have to come up with what we call the table of values.
For x-axis and y-axis?
Yes. Those that are, for those equations which have the inequalities that have two variables, x and y. If you compare these that we are looking at now with those that we had looked at in the first place, you're going to notice that they're different. These first ones only had one variable, x variable. Then here we only have the y variable, but here we have double, x and y. So now for you to draw a graph of such lines, you need to come up with a table of values. So you say this one will denote x and that one y. Now here, people get confused, like, where are you getting the values from? Just think of any number. But mostly I love starting from -2 and -1 through 0. Then you pick it up. From 0 you have 1 and then you have 2. Those are the values I'll place here. I'll say, okay, what if x is -1 and if x is 0? And then we are taking it that we are looking at the number line. So we start from -1, we'll move on to 0, 1, 2. So that's what I'm doing. So we have 1, 2, and the 3. If those are the values of x, what then will be the values of y? So what I'll do is, I will actually pick on this same inequality and I will transform it into an equation. So that is y is less than or equal to x. Okay. I will remove the inequality symbol from here and substitute it with equal, the equal sign. Then I'll say, okay, this is what I'm dealing with. For me to determine the value of y, I will be making use of this equation. So I say y, what will be the value of y if x is equal to -1? So where there is x, I write -1 there. So what is y? So this equation that we have now is saying y is equal to -1. So when x is equal to -1, y will be -1. What if we substitute x with 0? So y will equal to 0, right?
Yes.
What it is x and y are equal. So whatever value I'll pick on to be x, that will be the value that will actually denote y. So if x is equal to 1, y will be 1. If x is equal to 2, y will be 2. If x is equal to 3, y will be 3 as well. So we have all those values. We can now plot them on the x-axis and on the x or y plane. So we say this is 1, this is a 2, that is a 3, that is a 4, and that is a 5.